All right, well, good morning, good afternoon, whatever time of day it may be. All right, we're in section 2-5, chapter 2, linear functions and relations, and 2-5, scatter plots and lines of regression. And in this section, we talk about things like bivariate data, scatter plot, positive correlation, negative correlation, no correlation, line of fit, prediction equations. And that's what we're going to deal with in this particular little video. And then a little bit later on, we're going to add to that by talking about regression lines and correlation coefficients. But right now, we're going to use, we're being asked to use a scatter plot and a prediction equation. And in this video, we're going to use an Excel spreadsheet to help us develop our scatter plot and insert our line of fit. And then a little later on, we'll be using our TI-84 calculator or something similar to that to do regression lines and correlation coefficients, also plotting a scatter plot. So let's see what our problem is. This corresponds to page 93 on your textbook. Example 1, use a scatter plot and prediction equation. So here's what we're asked to do. It says the table shows the mean selling price of new privately owned single family homes for 6 years. And of course, here we got our table down here. It says make a scatter plot and a line of fit and describe the correlation. Write a prediction equation. Predict the selling price of a new home for year 8. And how accurate does your prediction appear to be? Now, the next slide, we're going to use Excel to make our scatter plot and our line of fit. Then we'll come back and write a prediction equation from what we see on our scatter plot. And then we will then predict, items C and D. 4 slides here that we're going to go through. So let's move forward, shall we? We shall. Okay, so we're over here on our Excel spreadsheet. We're going to enter the data from the table that we were given, create a scatter plot, and then insert a line of fit. So I'm going to go up here, cell 1, A1, and I'm going to label this year. I'm going to hit tab because I want to go to the next column. And here I'm going to put price, parentheses, in $1,000 increments. All right, now let's go enter our data as we've given. We got 0. I'm gonna hit the down arrow because I'm just want to work down the column for right now. 1, 2, 3, 4, 5. This should all correspond to what you see there on page 93 on the table and from the previous slide. And now I'm going to go in here and enter my data for prices. I got 154,500 is the mean selling price of new privately owned single family homes. 166.4. Data point number 2 at 181.9. Again, I'm just hitting the down arrow to navigate. 207.0. 228.7 and 273.5. All right, so we got our table put together. Now I'm going to highlight my 2 columns here where I got my data. I'm going up here, I'm going to hit insert, the insert tab up here. And right in here, I see that these are going to be scatter plots. I'm going to drop that arrow down. I don't want any of these lines right here. I could choose these options right here, but you can see that doesn't give me completely a linear equation because the line's got a little bit of curve to it. So I'm just going to choose the scatter plot. Now, to get my line of fit, I'm going to come up here to the far left, right here, where it says Add Chart Element. I'm going to drop that down, and I'm going to go down here to where it says Trend Line. And here I've got several options, but I am going to choose linear because I'm in the chapter section. I'm in the chapter of linear relations and functions. And I click on that, and you can see that it gave me a line of fit here, this little dotted line. And in looking at this, most of the data points are pretty close to that line of fit. And so I could then interpret and say that this has a strong correlation, and it's a strong positive correlation because I've got a positive sloping line, a line that is going up and to the right. Remember, a negative slope line is going down and to the right. This one's going up and to the right. The data points are very close to the line of fit, and so I say that I have a strong positive correlation. Now, in order to make my prediction equation, I got to choose a couple of data points because I'm going to take this from the slope formula, point slope, end up at slope intercept. That's going to give me my prediction equation. And I'm going to choose where x is equal to 1 and where it looks like to me that 0.3 is just a little bit closer to the line than 0.4. So I'm going to choose 0.3 where x is equal to 3. And we're going to jump over here to the next slide, and we're going to put together our prediction equation. All right, well, we did our scatter plot and our line of fit. And now we're going to have to deal with and make our prediction equation. And from the scatter plot that we put together, I think we were going to choose where x is equal to 1. This is our x value, the year. Our y values are the price. X is equal to 1 and 3. We could have probably just as easily chosen 1 and 4 from what the scatter plot did, but we're going to just use 1 and 3. So now what we're going to have to do to make our prediction equation, we're first going to have to go through the slope formula. And then once we get a slope, then we're going to go through point slope to end up with slope intercept to give us that prediction equation. So this here is going to be x1, x2, and here we got y1, y2. So let's go through our slope formula. So we got 207, 207, sloppy writing, minus 166.4 over 3 minus 1. Now that's going to equal, let me get my calculator here, 207 less 166.4 is 40.6. So we got 40.6, and 3 minus 1 is 2. And so we're going to divide that, 40.6. This is giving us our slope, and we're going to have a slope of 20.3. All right, now we're going to use point slope. So we've got, don't have a whole lot of room. We're going to go right here. So we got y minus y1, and I'm going to choose this these coordinates right here. Could have chosen what was on 3, but I'm going to choose this. So we got y minus y1, so y minus 166.4 equals slope 20.3 times x minus 1, because that's our x coordinate right there. That's our x1. All right, so let's solve. Now we've got y minus 166.4 equals 20.3x minus 20.3. And when I add 166 to both sides, let's drop this down here. Hope that's not too confusing. I'm going to end up with 20.3x plus, because I'm adding 166 to both sides. Let's see. Well, I can probably do that in my head. That would be 146.1. Okay. So that's our prediction equation. Now, depending on which points we used, our prediction equation could vary slightly. So it's not an absolute answer. It just depending upon what we use to calculate our slope, and then from that, then of course going point slope moving towards slope intercept. So let's take our prediction equation, and then we're going to move ahead and predict what's going to happen in year 8, and then make an assessment of how accurate we think that's going to be. All right, well, let's finish this thing off. It says predict the selling price of a new home in year 8. So we're going to just substitute in. So we had a prediction equation of y equals 20.3x plus 146 and 1/10. And we're going to plug in 8 for x. So we got y equals 20.3 times 8 plus 146.1. Remember, these are prices in thousands, these numbers we're using. Let's get our calculator here. So 20 and 3/10 times 8 equals 162.4. So we got y equals 162 and 4/10 plus 146 and 1/10, which is going to equal 308,000.5 or 308.5 or 308,500 is what we would predict for year 8. Given the trend we're seeing in that. If you remember at year 5, we were at 273.5. Now, D, how accurately does your prediction appear to be? Well, given the fact, and what we're really basing that on, is given the fact that we had a strong positive correlation in our line of fit on our scatter plot, then we would say that our prediction appears to be fairly accurate. Now, real world, this is housing prices. It does not always go up. It sometimes comes down. Given when the copyright of this book is, I think those years that we saw there probably reflected during the years of the housing boom. Well, we saw in 2008 and 2009 that house prices fell. However, that's another story. That's why you have to continually work on your predictions. But for the time being, we're going to say since there was a strong correlation, we feel like we got an accurate prediction. All right, there we go.